My name is Bhumi Patel, and I've chosen transportation and energy consumption as my topic for the final project. I'm looking into accessibility of methods of transportation as well as the energy consumption related to it. My main point of interest is looking to analyze transportation trends along with energy consumption trends to learn if the US is being distinctly impacted by the transportation sector, and I'm expecting to find out if an increasing reliance on the various forms of transportation in the US over time means an increase in overall energy consumption as well. And I also intend on determining if each state's total energy consumption ranks similarly to each state's transportation accessibility in comparison to other states. So for my data set, I chose my downloaded data set from a government website because that government website search allowed me to find the most amount of information regarding transport that I could that was good data. So that's how I found the bulk of my transportation information. And then for my energy consumption information, I just searched up statistics that I think would correlate with my transportation data that I found from the downloaded data set, and then web scrape those websites. So for my data cleaning process for the first downloaded data set, I just filtered the unnecessary and repeated data columns, and I changed the inconsistency that I found where the coordinates of the geographic coordinates were wrong. And then I created a few columns for percent statistics so it'd be easier to aggregate my data later on. And I filtered out unnecessary columns after I manipulated them into useful columns, and then I just ended up reading it to a clean file. For my second data set, I was web scraping. So I created headers for only the subheadings needed, and then I created my data set and handled an inconsistency where there were S values instead of an actual number, and then I was able to replace that. And I also replaced all the values from being like strings into floats so my aggregations would work. And then for the final data set, I just cleaned it by creating headers after scraping the website and then creating the data set like I did with the second data set, which was web scraped as well. And then I just also for this one added a new column with abbreviations for each state using a dictionary that I imported that I also created on the side because my other files had states abbreviated, so it'd be easier to aggregate the data and group them by their abbreviations if all of the files had that in common with each other. And then I just read that to another new file. I talked about a few of the inconsistencies while I was going through my data cleaning process, but overall the main inconsistencies were just dropping duplicated data and unnecessary values that didn't contribute to the data set, and changing values that were like strings into like floats so I could have better aggregations in phase 2. So now we can go to the data analysis portion of this project. So for my first insight, I wanted to ask the question, how do each state's total amount of transportation locations and energy consumptions compare? So to do that, I just found the rankings for all the states based on their transportation locations and their energy consumption, and then I just displayed that on a graph per each state, and this would allow me to see for each state, like, oh, this state has, Alaska has a very similar rank, this state, California, has a very similar rank, and so on. And also, to get a more concrete comparison between the two, I found the Kendall rank correlation coefficient, which is a ranking correlation coefficient, and I found that the value was 0.65, which is a pretty positive moderate correlation. So that's meaningful because it tells us that the two statistics have a direct relationship, and that means that usually when the amount of transportation locations in a state increase, then the total energy consumption for that state will also increase, and thus having similar ranks. For my second insight, I asked the question, how has the total count of transportation methods changed over time for each state, and does that reflect onto the state's energy consumption? So I found the total count of transportation locations for each of my time frames, and then had added a column where I could see the trend of the total count across this time frame. And this was meaningful because I could see from the table that when the total count of transportation locations in a state decreased over time, the energy consumption in that state would most likely fall in the bottom 25 rankings of the energy consumption. So for example, we can see here Arizona was decreasing and it had an energy rank in that was 31, and Wyoming was also decreasing and it had an energy rank in 41. For my third insight, I asked the question, does the most prevalent form of transport across all states have any relation to the most prevalent form of energy consumption from a certain form of petroleum? So I just found the percent average of the most prevalent forms of transportation across all states and the percent average of energy consumption across the various forms of petroleum. And for my max in this category, it was the bus transport, and for my max in this category, it was the motor gasoline. And this is in line with each other because buses use motor gasoline to function, and that's meaningful because it just shows that the type of transport can cause varying contributions to the percentage of energy consumption from U.S. transportation sector. For my fourth insight, I wanted to see if there was a correlation between state population and state energy consumption. So to do that, I just created a little graph and I found the correlation coefficient between those two statistics, and I found that to be 0.85, which is a strong positive relationship, and that's meaningful because it tells us that for states in the US, as population increases, energy consumption will also very likely increase. For my fifth and final insight, I asked the question, how much energy consumption from the transportation sector contributes to the total energy consumption of the US? And to do that, I just found the total transportation energy from the transportation sector, and I found the total energy consumption overall in the US, and then found the percentage from these two statistics here to be 29%. And this is meaningful because we can see that it's a little less than 1/3 of the total energy consumption in the US, and from that we can confirm that large changes in transportation use will affect the proportion of total energy consumption. And it allows us to also acknowledge that a change like increasing the amount of transportation methods available for use would directly cause an increasing change in our proportion of interest. So more energy is being used via transportation. For my first visualization, I created a geograph, and this graph easily indicates where the most total transportation locations are, while also taking into account the populations of those areas. So the population size is indicated by the size of the circle, and the total transportation location amount is indicated by the color of the circle. So from that, we could just see that like the Northeast has a large amount of transportation locations just by the sheer density, and like specifically California has a large amount of transportation locations because the population is high. And this is just meaningful. This trend is meaningful because it shows that countries with high populations are more likely to have a larger amount of transportation locations, since their greater population would need more forms of transport. For my second visualization, I created a lot of line graphs, and these graphs show the energy consumption of various forms of petroleum over time. And then from this, we could see that, for example, the total energy consumption in the US decreased from 2006 to 2012 and then increased from 2012 to 2018. And we could also see that other forms of petroleum followed a similar trend, such as motor gas, whereas others were consistently decreasing or consistently increasing, like this. And this was just overall meaningful because we're able to see the difference in trends for energy consumption over time depending on the specific form of petroleum. And for my last visualization, I created a visual that displays the change in the amounts of total transportation locations for each state in my time frame. And that allowed us to see whether each state increased or decreased their total number of transportation locations. And the trend we were able to identify was that from 2012, the number of transportation locations increased and became their highest in 2018. And that's meaningful because it could indicate why there may be a larger amount of energy transportation consumption in the span of 2012 to 2018. And that's just overall it for my graphs. And in conclusion, I was able to learn that most transportation trends do align with energy consumption trends in the US, as shown by the explanations for insights and visualizations. And this holistically means that the US is being distinctly impacted by the transportation sector in regards to energy consumption specifically. Thank you.